Hello everybody and welcome to the second practice video for 2D vectors. From the question we know that AB is 2i plus 7j and AC is 4i minus 5j. We also know that D lies on the line BC, so it cuts the line in the ratio 1 to 2. Now we're asked to find an expression for BD, and as you can see from the diagram, BD is exactly 1/3 of the line BC. Now BC is exactly the same as going from B to A to C. And BA is the same as minus AB because the magnitude is exactly the same and the direction is exactly the same in the opposite direction. So we can write BC as minus AB plus AC. And if we put the values in, we end up with 2/3 I minus 4j. Now for part B, we have to work out the magnitude of AD. Now AD is equal to AB plus BD. So if we put those values in, we end up with 8/3 of I plus 3j. So that gives us the vector AD, but to find the magnitude, we need to take the square root of 8/3 squared plus 3 squared. I'll leave a link in the description below to the previous video if you didn't understand that. So that's equal to the square root of 145 over 9, which is 4.01386, and that is approximately 4 units. So in the next question, we're given 3 vectors, OA, OB, and CB, which we can write down on a sketch like this. Now for part A, we're asked to find the vector AB and hence state its length. Now as AO is the same as minus OA, we can write AB as minus OA plus OB. And putting these values in gives us AB is equal to 4i plus j. So the length of AB is going to be the square root of 4 squared plus 1 squared, which is equal to the square root of 17. Now for part B, we're asked to find the length of AC, but first we need to find the vector AC. Now AC is equal to AB plus BC. That's also equal to AB minus CB. And putting the values in gives us 5i minus 5j. So the length of AC is going to be the square root of 5 squared plus 5 squared, which equals the square root of 50. Now for part C, we're asked to calculate the angle ABC. To do this, we'll have to use the law of cosines. Now with the law of cosines, we'll need the length of AB, the length of AC, and the length of BC. Now we have the first 2 lengths, but we don't have the length of BC. So the first thing to do is to work out that length. Now we already have the vector CB, so it should be relatively easy to work out the length, which is the square root of 1 squared plus 6 squared, which is the square root of 37. So now we can tidy up the diagram a bit and take off the non-essential lines and add on the lengths of the sides of the triangle. And remembering that the length B is opposite the angle B and the length A is opposite the angle A, etc., we can put the numbers we have into the equation and we get this. The squared and the square roots cancel out like this, and then 50 minus 37 minus 17 is equal to minus 4, so we get this. Then if we rearrange for the cosine of theta, that is equal to 4 divided by 2 root 37 root 17. And putting this into a calculator, we get 0.079745. So theta is the arc cos of that number, which is 85.42 degrees. In the last question, we're given the trapezium OABC, and we're given the position vectors of A and C. The question states that CB is parallel to OA and is twice the length of OA. We're also told that D lies on the vector AC and splits it in the ratio 1 to 2. So for part A, we have to find an expression for OD. Well, OD is equal to OA plus AD, and AD is along the vector AC, so we'll have to find an expression for AC first. To get an expression for AC, we have to go along the vector OA, but in the opposite direction. So it's minus OA plus OC. And when we put the values in, we end up with AC equal to 6i minus 25j. And as point D splits the line AC in the ratio 1 to 2, AD is going to be 1/3 of AC. So if we put the values in there, AD is equal to 2I minus 25/3 J. So now we can put the values in for OD equals OA plus AD, and we get 14I minus 13/3 J. Next, we need to show that OD and B are collinear, which basically means they're on the same line. So we want to find the vector DB and OD and compare them. Now first we'll find the vector DB. Now for this we need to find the vector DC and CB. Now CB is twice OA, so it's 24I plus 8J, and DC is 2/3 of AC, so it's 4I minus 50/3 of J. And DB is the sum of both of those, so it's equal to 28I minus 26/3J. Now we worked out the vector OD in part A, so now we can write down OD and DB next to each other. Now as you look at them side by side, you can clearly see that DB is exactly twice OD. Now this proves that they are collinear because one is a scalar multiple of the other, and they also share a common point, which is D. And because we know DB is twice as long, we can state that the ratio of OD to DB is 1 to 2. Well, that's it for this video. So as always, thanks very much for watching. And if you could smash that like button for me, that would be great. And hit subscribe to receive more videos like this. I hope to see you on the next one.